In this video, we're going to learn about the GCD, or Greatest Common Denominator Codec, introduced in ClickHouse 23.9. This codec works well if you have large numbers that change in big increments. Let's see how it works with help from an example. So you can see here on the left-hand side, we've got some very big numbers. And what's going to happen if we use the codec is that the numbers are all divisible by 1 million. So we'll kind of pull aside that 1 million, and that's the greatest common denominator, and then we'll divide every number by 1 million, and then on the right hand side we get the values that will actually be stored. And then what happens is when you query values in that column, they will be converted back to the original by multiplying each value by the greatest common denominator. Okay, so we're going to come over to the terminal and try this out with a dataset. So we'll launch ClickHouse local with the -m flag for multi-line queries, and then we're going to set a parameter URL, which has a link to a Forex dataset. So let's have a look what it looks like. So we're going to call the select star from the S3 table function. We'll pass in our URL. We're going to tell it it's going to be a CSV with names. So that means it's got a header. And then we'll get just one entry and we'll tell it to format it in vertical format. And you can see we get back, we've got a date time, we've got a bid, ask, base, and quote as well. Now we're, for the purpose of this video, just going to look at the bid column. So what we're going to do is we'll create a table called Forex. We'll pass in the date time, the base, the quote, and then we're going to pass in a variety of different bid columns. So the first one is going to be with a very, very big decimal, so decimal 7638, and we'll give it just the ZSTD codec. The second one is going to be the same, so 7638, but this time it's going to have GCD and ZSTD. The third one will be a bit smaller, so a more compressed decimal. So this one's going to be an 11 and 5, again with ZSTD, and then the fourth one will be 11 and 5 with GCD and ZSTD. And we'll give it the engine and then the sorting key as well, and create that table. Now we're going to insert some data into the table. So we'll say we'll insert into Forex, date time, base, quote, and then bid is going to be bid 4 times. So bid as bid v1, bid as bid v2, bid as bid v3, and bid as bid v4. And then we can say, hey, it's going to come from that S3 URL. We'll do 10 million rows. That should be enough to see how this codec works. And then we need to pass in this extra setting. So use structure from insertion table in table functions needs to be 0. And so what that will do is it will tell it, hey, I want you to read the structure from my query rather than from my table, which is necessary because of all the aliasing that we're doing. And if we give that a few seconds, it will load in all of our rows. Now we're going to write a query that has a look at the size of the data in our table. So we're going to say we're going to get the name, the type, the codec, a readable version of the compressed bytes, and then a readable version of the uncompressed bytes from the system.columns table, where the table is Forex and the name is bid. So it's only going to get our table. And if we get back the result, you can see we've got on the first row, this was the 7638 with just the ZSTD. So that's got 11.35 megs compressed and 305 uncompressed. Now, the uncompressed values are unimpacted by the codec, so they only come into play on the compressed values. And so you can sort of see, if you look at rows 1 and 2, we need to compare those, and then rows 3 and 4, we want to compare those because those are using similar types. It's probably easier to see with another version of this query. So we're going to, this time, just compare the ones that have exactly the same column type against each other. So we're going to say, hey, get me the type. I want you to do a readable size for summing the compressed bytes where the codec is like GCD, and then we'll do the same thing where it's not like GCD, again from the system columns table, and again just for Forex and bid. And then if we get back the results this time, now it's a little bit easier to see what the GCD has actually done. So we can see on row number 1, we've got the decimal 7638. GCD is 10.96 meg, and not GCD is a little bit bigger, 11.35 meg. So not a massive difference, but it obviously would get a bit more substantial if you had more data. And then if we look at the second row where we reduced the precision of the decimals, we did 11 and 5, then we've got 7.48 meg and 8.38 meg. So even on this relatively small dataset, we've saved some space by using this codec. And if you want to learn more about new ClickHouse features, check out this video up here, which explains the JSON inference support also added in ClickHouse 23.9.